Okay, so this video is about how to use Desmos to graph parabolas and quadratics and find the solutions, its end behavior, its x-intercepts, its y-intercepts, its vertex, its axis of symmetry, and so forth. So we can go to Desmos. I can type in y equals, and we plug in 3x. So I'm hitting the number 3, x to the second, x to the second, plus 14x. I'll work this one out so I know what the solutions are. Plus 5. And now it should graph instantly. And when you graph it, you might not see the entire graph. You might have to zoom out a bit to see the whole graph. These are the solutions. One of them is at negative 0.39, and another one is negative 4.2770. So our solutions have the x values being numbers and the y values being 0. Sometimes x might be 0 and y might be 0 too. But if x is 0, anyway, sometimes it could have, our solution should be where y is 0, right? So if y isn't 0, that's not a solution. So you're looking for y is 0, and these have the x values there. So we actually looked at the graph's vertex is down here. You just click on it, and it'll tell you the vertex is negative 2.33 and negative 11.33. Our axis of symmetry is the same number as the x value for the vertex. So our axis of symmetry is x equals negative 2.33. Now some other stuff I want to mention about the graph, like if I zoom out more and more, the graph doesn't stop going up. So it goes up forever. So, and it goes to the right forever too. Right and left forever too. So we're going to talk about domain and range and that kind of stuff next. But that's just how you use Desmos to actually graph it. Now let's actually talk about all those features I mentioned earlier. All right, here's a picture of a graph. It's already been graphed in some graphing calculator. And I'm looking at it. Let's talk about all those features. It says on the bottom, say domain. Let's come to that last. All the domain for every one of these. Domain for every quadratic is always going to be negative infinity to infinity. So don't sweat the domain. They're always going to be the same. They never stop going to the right. They never stop going to the left. Meaning it crosses all the x values there is. So domain is always going to be the same thing for these. Negative infinity to positive infinity. So when in doubt, just know for quadratics and parabolas, domain is always the same. And the range always changes too. But let's come back to that in just a moment. I want to talk about the vertex and axis of symmetry. All right, so the vertex is clearly right here. And I'm going to make it a coordinate. So that coordinate looks to be, you start at origin, and then you go over and then down. I don't go over, but I do go down 3. So I go over 0 and down 3. So my vertex is at 0, negative 3. This is my vertex. My axis of symmetry is where it's going to be this line right here in the middle. It goes to the vertex. So this is my axis of symmetry. And it's just x equals 0. It's x equals whatever that x coordinate of the vertex is. Always. Always going to be the same thing. Whatever that x coordinate of the vertex is, axis of symmetry always going to have the same number. All right, now the solutions to it you can see as well. It's going to be these coordinates right there. All right, so that solution looks to be, if this is at negative 1, that's at negative 2. I'm going to say that's about negative 1.7. And if I check the other side, that looks to be about the same. You can't see it where I have it written at, but x is positive 1.7. So those are solutions for it. You can find out exactly what they are by solving that equation some sort of way by. And we learn other ways of solving equations other than factoring. But that's what the solutions are. Now, let's talk about its range.